So for this example, we want to use polynomial long division to divide x cubed plus x squared minus 1 by x minus 1. Okay, so normally I'd just give you a graphic and we'd process through it in that way, but I'm going to try and write this out here because, for one, I like it a little bit more handwritten. It goes through the steps a little bit more carefully, but just understand and pay some close attention here because I know my handwriting isn't the very strongest. And we're going to start here by arranging these in descending orders of their power x, where I'm going to start with x minus 1. So I have my x minus 1 here, and then we're going to use that tableau division-y thing. We're going to draw it out there with a little bit of extra space because we might need a little bit of extra space. And then we're going to draw in our dividend, which here is x cubed plus x squared. And I'm going to do something that isn't necessarily required, but I think helps make clear what's going on. Instead of leaving a gap in there or just not writing it at all, I'm going to put in a placeholder for the x term that's implied but isn't written, that we have 0 x's in there. Because we're going to want that space later, and the nice thing about math, the nice thing about our system, is that based on the way zeros work, they might not always be there, but if we ever need one, we can always carry another 0.
I can't carry it for you, but I can carry you! Come on!
And from here, we're going to follow through on our steps. So we've got our pieces written out, and we're going to divide the first term of the dividend by the first term of the divisor. So that means we're going to divide this term here by that term there, the x cubed by the x, and that will leave us with an x squared, which I'm going to put up here. You always try to match these things up because it helps with the order a little bit if you do that. It's a good habit. You aren't required to, in the same way that you aren't required to match up your things nice in aligned order when you're talking about numeral long division, but it's a good habit. So I'm going to put that x squared here to say that I have one of them. And then I'm going to multiply this through in here, and we are going to be subtracting x squared times this. So that's x cubed minus x squared. And there, the x cubes are going to cancel, and we'll have a double negative with that x squared. So we're going to get a 2x squared, and, well, the instinct here would be to carry down the 0. So I'm gonna carry down the 0, even though it doesn't really do anything, just to know it's there. And at this point, we're going to repeat the process in terms of these guys, where if I divide the 2x squared by x, what's going to happen is I'll be left with a 2x. So this is why I included that 0 in there, just because it gives nicer alignment if I'm going to keep those things in that order. I'm going to keep my rows in a duck, as it were, and then we're going to repeat the process. So we're going to go in here, 2x times that value would give me a 2x squared, 2x times that value there would give me a minus 2x, where again, we're chasing around some serious double negative values here. There's a whole lot of negativity that ends up being pretty good because we have 2x again, and we're going to now carry down the 1. I want to keep these lines dashed, so I'm going to dash that line there, and we'll have a 2x minus 1, and then at this point we're going to divide again, where now we're going to have a 2x over x. That's going to leave me with a 2, and we're going to pull down 2x minus 2, and hey, at least we're finally doing a subtraction there, but in this case that double negative turns to a positive, subtract 1, and we are going to be left with a 1. So I got ahead of myself when I said that this thing is actually a factor, because it's not quite. It's off by just 1. We're so close. Not good enough. Because what we end up with here is our quotient, 2x plus x squared plus 2. I don't know why I said it that way, but I did. So we're going to get that. X squared plus 2x plus 2. And unfortunately, because we get down to here, we have this value 1, that's of lower degree than x. Nothing we can do with the division will make that any better, so we're just stuck with it as a remainder, and we write that as 1 over x minus 1. Like we always do when we're talking about things with remainders before, they turn into fractions. Here, these turn into rational pieces, and we'll define more carefully what it means to be rational later, but that's how we notate our remainders, where if that happened to be a 0, we wouldn't have one, and this would be a nice factor. This would be written in the way we want it to be, and all would be good. That doesn't often happen, though. Usually we do have some sort of remainder to deal with. Anyway, this is how you do polynomial long division. It works for the exact same reason as is regular long division, just like I said like 4 times already. But it's also clunky. So we're going to see next a method that we have for doing this, at the very least, in a more compact notation called synthetic division.